Hello. Okay, so this is basically a continuation of the other video. Um, this basically just shows you some example problems. Okay, so let's say we want to translate each of the radical expressions here all into rational exponents. We want to change all of these radical expressions into rational exponents. Okay, so just as a reminder, the rule I went over last class was that the nth root of a raised to some power m is the same thing as a raised to the m divided by n. Okay, so if we want to translate the radical expression here, this part is n is 5, m is 4. So this is basically x raised to the 4 over 5. Yep. This one, what I mentioned in the last video, right? In the last video, if you don't see a number here, you assume that it's a 2. You assume that it's a 2. So when you rewrite this, this is basically z raised to the 5 divided by 2. Z raised to the 5 divided by 2. This one is w raised to the 7 over 3. W raised to the 7 over 3. This one, assume there's a 2 here, so this becomes x raised to the 3 over 2. X raised to the 3 over 2. This one is interesting, so same idea. This one is y raised to 6 over 4, and the reason why I said this one's interesting is you can actually reduce this fraction. You can reduce that fraction. 6 over 4 is the same thing as 3 over 2. 6 divided by 2 is 3, 4 divided by 2 is 2. Yep. And this one, what you want to do with this one, so this is the same thing. Assume that there's a 2 here. So this is basically y raised to the 12 divided by 2. So this can actually be rewritten as y raised to the 6th power. It actually wouldn't be a rational exponent, but this would be it in its simplest form, basically. Okay, let's see. So I have these examples here. Let's say I want to work backwards. So I want to translate the rational exponents that we see here into radical expressions. Okay, so if we were to go backwards, so we're going to use that same rule that we applied here. So we're going to use this here. Okay, so I'll rewrite that here just to refresh your memory. So the nth root of a raised to the m is the same thing as a raised to the m divided by n. Okay, so now we're going to try to go backwards. So if we go backwards now m is 3 and n is 4. So this is just the fourth root of x cubed. Fourth root of x cubed. Okay? If we go backwards, so now the 2 here, if you had to think about it, this is basically, if you had to rewrite it, it would look like this, right? But what I said earlier, remember what I said earlier, if you have a 2 here, we already know that this is a square root. We already know that this is a square root. We don't need it. It's gone. It's gone. Woohoo! Okay, next one. Z raised to the 2/3 power. Okay, so what we do for this one is basically, this is the cube root of z squared. The cube root of z squared. Okay, this one, what we would do for this one is same idea. So this is the top number is m, the bottom number is n. So this is the 7th root of y squared. 7th root of y squared. Okay, this one. Again, now if we rewrote this, you would put a 2 in front, and this is basically w raised to the 9th. Again, what I said earlier is that we already know that this is a square root. If we already know that this is a square root, then we don't need that. As you kind of see a pattern here, the purpose of the number here, this tells me that this is a 4th root. This tells me this is a 3rd root. This tells me this is a 7th root. And yeah, so because we already know that that's a square root, we don't need the 2 there. Okay? And then this one. So what we have here, do the same thing. So basically the 2nd root, or in other words, the square root of y cubed. And what's going to happen is the 2 will vanish. The 2 will vanish. Wow. So cool. So cool. All right. Show you a few more examples. All right. Simplify each of the following expressions here. All right. So, as I said earlier, right? So, imagine that if you don't see a number here, there's a 2 here. So, this is the same thing as 5 raised to the 4 divided by 2. Reduce this. 4 divided by 2 is 2. So we're dealing with 5 squared. This is, again, and I see some of you just struggle hard with this. This is not 10. This is 5 times 5. So 5 times 5 is 25. Okay? This one looks intimidating. 7th root of 3 raised to the 28th power. So this is basically 3 raised to 28 over 7. 28 divided by 7, if you do not know what that is 4. So 20 divided by 7 is 4. So 3 raised to the 4th power. So now, in order to simplify this, we're doing 3 times 3 times 3 times 3. So 3 times 3 times 3 times 3 is 81. Yep. All right. Next one. So the cube root of 7 raised to the 12th power. Okay. The cube root of 7 raised to the 12th power. So what I see for this one is, again, if we rewrite this, this is 7 raised to the 12 over 3. 12 divided by 3 is 4. So we're dealing with 7 raised to the 4th power. So we're doing 7 times 7 times 7 times 7. And I'm using a calculator. This is 2,401. 2,401. Okay? This one, you don't see a number here, assume it's a 2. We rewrite this. This is 4 raised to the 6 over 2. 6 divided by 2 here is 4 cubed. Now we're doing 4 times 4 times 4, which is 64. Okay, this one, again, assume there's a 2 here. There's no number. So this is basically 2 raised to the 8 divided by 2. 8 divided by 2 is 4. So 2 raised to the 4th power, 2 times 2 times 2 times 2 is 16. Okay. This one, 9th root of 12 raised to the 9th. All right, so what we would do here, this is basically 12 raised to the 9 over 9. 9 divided by 9 is 12 raised to the 1st power. Or in other words, it is just 12. It is just 12. Yes. And that is it. Those are your 18 problems on this concept. All right? Let me know if you have any questions. Okay, bye-bye.